So hi everybody, I am Jennifer Rennels and I'm a professor in the psychology department, and I study the development of face perception and face processing, especially in relation to differences in infants' experience with people based on gender and race, and how that affects their face perception and processing abilities, and how those might actually serve as precursors to the development of stereotypes and biases. The reason I'm telling you this is kind of just give you a little bit of background in my research, and I also want to get a sense of the research everyone's doing in here. So the first time I mentored undergraduate students was when I was a graduate student, and I still do to this day, although my graduate students tend to have more hands-on experience. So I think we're a small enough group if we just can briefly go around the room, and so I get a sense of what everyone's going to be doing. So can we start here?
Sure. My name is Self-Efficacy. I'm a Ph.D. candidate in electrical engineering. I'm mentoring two undergrad students for the RAMP program and the Office of Undergraduate Research.
Okay, great.
On basically like security of the internet.
Thank you.
So, Dale Harris. I'm a grad student as well, Ph.D. student, also Canada.
Congratulations.
I have civil engineering for my undergraduate physics, and we're doing a project for optimization of morphology of sexually selective regulators.
Great, thank you. Go ahead.
My name is Stephanie. I'm from physics, and I usually have undergraduate students present on life sciences because we do a lot of biological work.
Timothy Thatcher, doctor in medical physics, student.
Great, thank you.
Hi, I'm Kaya. I'm in the Ph.D. program in science education. It's my third year.
Hi, I'm Jennifer Rennels, and I work in the Phillips Center. So I deal with more of the community people.
Great, thank you.
You know who I am.
I do, but maybe everyone else doesn't.
I'm just in London. I am a PhD student in the Department of Psychology. I mentor a ridiculous number of undergraduates, both in research and in getting into graduate school and progressing through psychology as a degree. My name is Gina. I'm a PhD student at the college. I work with students not only to be in hospital, but
I'm Anthony Jordan with the Department of Political Science, Ph.D. candidate, and I'm here as part of the mentorship certificate. And I'm teaching right now, so I'm hoping something I learned I can actually put in the action class, make it more interesting and enjoyable.
Me too.
I'm Jeff Boone, public affairs. I don't necessarily mentor anybody specifically right now.
Okay, thank you.
I'm Luca. I'm in the Department of English. I'm pursuing an MA in Reader Study. I can finish 101 semester, and I'm returning the writing center. I did it for 10 years. And yeah, it's like right here. I'm to learn and I'm basically apply to my classroom.
Okay.
I have a whole calendar of events, so I just like highlighted this.
Okay.
Hi, my name is Olivia, and I am a graduate student. I'm doing my master's right now. I work with Nikki at the Academic Success Center. We're mentoring students over there. I would like to gain more experience as to how I can be more beneficial in what I'm doing to help students get on the right track.
Okay. So up front, I geared this toward mentoring students in a research setting. And of course, everyone in here is from different areas of study. So I'm trying to keep it broad so that you can take what I'm giving you in my own approach, but utilize it in your area of study. But I'm happy to stop at any time and kind of talk about maybe how that would work for your field of research versus mine. Oh, why does it do this? This doesn't like me today.
When in doubt. It's not more.
No.
One you have
No. Mentoring undergraduates.
V3.
Yep. Don't completely rely on PowerPoint is my first role. Yeah, but when you go to change the page, it does that. It's really weird.
But if you zoom all the way in on that slide.
If I just, yeah, okay. Okay, it's okay. Okay. Take two. Take three. Okay. So I was trying to capture everything that mentoring does, and I found this Google image, so thank goodness for that. A lot of times you might think of the training component in terms of mentoring, but it comes along with giving advice, motivating students, supporting students at times too, because life happens while we're mentoring students, and also helping them to be goal-oriented and motivated, giving them some direction, and then when they do succeed, you know, enjoying those rewards with them, right? So I want to kind of go through some things I do first off the bat in terms of expectations. I set out up front and how students are going to be evaluated, because I think that people should know that up front. And then I'm going to talk about the different types of mentoring that have come out of pretty much interviews with scientific mentors and how they instill confidence in their students. So off the bat, one of the things I do with my students is I let them know what our expectations are. Now you don't have to exactly do this, and I know that may not be a good fit, but I still think it's good to let students know up front maybe what your expectations are, whether you have rules for your lab and all that. So one of the things I have my students do is they read this contract and sign it on their first day. And I didn't do this when I first got here, but due to issues of students using social media or downloading things that cause viruses on my computers or not showing up, I felt it was important to put these out there right up front, that these are my expectations. And I can tell you that it's really minimized having those issues that can interfere with the actual thing that you're trying to do, which is do the research and the mentoring, right? So the first thing I let them know is, you know, we have you scheduled for hours, and I don't know how it works in all your labs if you have set hours, but pretty much we have it set around the student's schedule, that this is when you're expected to be in the lab and you're expected to be there for the full time and on time. And if you can't be there, to try and get someone to take your place, because in my case, sometimes we have appointments, we have families coming in, and so we need people there to help run the studies. Sometimes we need more than one person to run the study. Sometimes we need someone to watch siblings while parents are in there with their infant or another child. So it's really just ensuring that. Also letting them know that, you know, we understand people get sick, people have family engagements, but excessive absences, which we say 3 or over 3, can potentially impact their grade, or, you know, ultimately this is to let them know what's important for their grade and for a letter of recommendation. So essentially letting them know these things are important. And if they do miss their scheduled time in the lab, that they try to make it up within 2 weeks so that we can get them back on track and all that. The other thing is that we have lab meetings. We have lab meetings to discuss on the lab. My students write a paper, so we have meetings about writing the paper. And we do that. We have several different meetings for writing different sections of the paper, and we expect students to attend those and come prepared to have questions and engage in discussion. So they know that as well. And then I think a really important one is just this notion of that professional work ethic, right? We're collecting scientific data in this lab, and the hope is that it's going to get published in a scientific journal. So integrity in all aspects of the research. When it comes down to following protocol to the T. If there is a problem, report it so that we can investigate, did it interfere with the data collection. We also have a database full of families' information, and one of the things we do when you're working with human subjects is ensure their confidentiality. So ensuring that there's that confidentiality and they're not talking about, hey, such and such came into the lab today. And also just interacting with participants, and I know not all of you are doing that. Some of you are interacting with particles and all that sort of thing. But, you know, treating them with respect and integrity, and not just the participants, but also other fellow lab members. And I also had this issue early on where there was a big interpersonal problem going on with some lab members. And I found myself wasting a lot of time every week talking with them about the problem. So I set up this thing, look, if there's an interpersonal problem, I expect you to just try and solve it at your level. And then if it gets to the next level, bring it up to me, but really try to resolve it at that level. And that has alleviated a lot of people coming to me. We're all adults working together. So, but at the end too, there are some times where it's difficult and they need a graduate students or my help, and that they should feel comfortable coming to us too, and we let them know that. The other thing is the notion of using the equipment, that the equipment is there, it's there provided by UNLV or my funding agencies. And so if students are using your equipment in the lab, it should be used for the scientific purposes only and not for personal use, and making that clear up in advance. We even had one time a participant came in who was a student, asked if they could do their homework. And I said, you can't have them on our lab computers where we have sensitive information. So things like that, letting students know ahead, not to be on social media or downloading. Most of your mentees will probably get keys to your lab space. That those are to be used when they're supposed to be there and not to bring other people in. There's usually sensitive information, scientific experiments going on. If they really want to give someone a tour of the lab, that they have to get permission ahead of time, that it's not just you have keys and it's a free-for-all. And maybe this seems obvious, but it wasn't always obvious until I made sure that they were stated up front. And also who the occupants should be in the lab. The occupants in the lab should be our participants and the students that are working in there, and that's it. And visitors need permission. But the last thing that I put on there is that the lab is a learning environment, and that we have a set level of skills that we want students to acquire. And I'm assuming as mentors of these students, you also have like a set skill set you want them to acquire and obtain. But sometimes there are students that just nail that right away, right? They're really great. And so I let them know ahead of time, we are happy to raise you higher and teach you more, but let us know. Say, you know, I've got this down, now I want to learn more about designing studies, or I want to learn more about these data analyses, or I want to learn about auditing heart rate or using the eye tracker, you know, these. And so, you know, maybe they want to know about more complex studies that are going on in your lab. So, but telling them that you need to bring that to us when you're ready and you want that, and then we'll be happy to offer you to that. So also opening that up so that they can make the most of their learning experience, and you know that they need what they need. Questions or comments? Yeah.
So this was condensed from an earlier version?
No, this is pretty much our current version right now. Yeah. No, nothing was, I actually didn't used to have a contract, and then what happened is that this sort of evolved as a result of that. So yeah.
What's your general disciplinary action if one of these things are violated?
Luckily, it hasn't been in a while, but usually there's a meeting with the student where we talk about the concerns. And if those persist, then there's a warning letter. And then if it still goes on, they're dismissed from the lab. So I like to kind of keep it at a undocumented level to a documented level to a done. Yeah. Any other questions? But like I said, putting these things out there has made problems in my lab much lessened than when I first got here and didn't put all these things up front. So I think it's helped a lot. The other thing is there's a very good chance that at some point the students that you're mentoring are going to want a letter of recommendation from you, or it may be that you need to assign them a grade or both, right? So, so when I developed these things, like how are we going to evaluate you, I thought about what is often asked for in a letter of recommendation, what do people want to know about, and then also what are the lab skills that I want students to attain when they're working in my lab. So we also give them up front sort of this notion of what you're going to be evaluated on. And if they're getting a grade, pretty much they write a paper about a study that's going on in the lab. But for you and your students, maybe they're going to be presenting a poster, for example, for the Office of Undergraduate Research. But I would encourage you to have some sort of culminating experience planned for your student, whether it's writing a paper and or giving a poster presentation, so that they have a way to piece together, you know, the methodology they've been working on. They get to, you know, do some work with the data, and they're connecting other literature to what you're doing with the study, and they're able to, you know, take aim at trying to write a discussion section. And I realize that that's maybe limited to my area of study. So in political science, you don't necessarily have that, for example. So what might be a culminating experience for a student in your area of study? For like a research mentee, yeah.
In a class, it's probably a paper.
Mm-hmm.
And then maybe on that undergrad level, maybe like a thesis or something, you know, something to that, some type of project that shows your skills that developed at the time. Write something that's maybe not quite ready for being published, but shows, you know,
Right.
you know, more time in the system, you'll get there.
Right. Essentially getting a chance at sort of, you know, the first step to getting comfortable with what is relevant in your field for writing up a research report. And what we do is, in this case, we divide it into sections, and they have a meeting about each of these sections, like the method, the intro, the results of discussion. And so for you, it might be a little bit different. But then there's a chance at the meeting to ask questions and learn what goes into each of these sections. And then they write a draft of each of these. They get feedback for each section, and they incorporate that into the final paper. So they don't just get a shot at writing, they also get feedback on it to improve their professional writing. And then we pretty much grade them on how well they incorporated that feedback into their final draft. And so then some of the other things that I talked about that were part of the contract was, you know, just what was your attendance? Were you prepared for these meetings when you attended and all that? I have my students write a weekly lab report, and maybe it's because I'm anal, but I have about 15 undergraduate students in my lab a semester and 3 graduate students. And so I can't be in the lab most of the time, certainly not all the time. So this is a way for me to know what happened this week in the lab. And so my students will write a report about what they did, how they spent their time. And this is a way for me to say, A, they're picking up things quickly and they're doing it in an appropriate amount of time. B, it's also a way for me to identify maybe a potential problem in the lab where someone's like, oh, I went to find these data files and I couldn't find them, and then I can bring it up, right? But it's also a place for them, and I also ask them to like set their weekly goals as a, you know, aspiring future scientist, hopefully, that it's a good thing for students to be goal-oriented. So we ask them to plan weekly goals and put those in their lab reports, and then they talk about whether they met those or not in the subsequent week. But it's also a place to ask questions like, I'm not sure why you're doing this, you know, and then I can start a conversation with them. And it's also a place for them to offer suggestions, like, I can see a better way to run the lab efficiently. So for example, we do a lot of confirmation calls to remind parents about their appointments. We have one study where parents come back every 2 weeks. And so, you know, that can take time sending these reminders. So this one student recently suggested, why don't you try Google Voice with this automatic texting, you know, and I need these younger students, you know, about this stuff to tell me about these things. So I appreciate and encourage suggestions like that. So, you know, and I would encourage you to think about it, you know, when students have a perspective or an idea, it's really good to listen to them and think about it at least and acknowledge that you appreciate that input. And then this is sort of the listing of the lab skills that I expect them to have. They're varied and they're going to be different for your students, but this way they know up front, you know, by the end of the semester, I expect that you can schedule infants, that you can code their behavior, that you can conduct a study, and that you can file paperwork appropriately away in the right place, that you know how to handle updating our various databases, et cetera, so on. And then certain school students will add different skills depending upon their skill level or certain tasks we get them. But that way they know. So this is kind of like the basic that I was talking about that we want them to meet. And then when they meet that, then we can give them additional. So for some of you in your, for your mentoring, what would be some basic skills that you would expect them to attain while they're working with you on a research project? You want to offer? Yeah.
General increase in writing capability, trying to encourage there's the fellowship applications if they're in their senior year that they should be applying for right now in addition to the grad school applications. So a lot of that practice in addition to lab reports and the monthly updates in that program.
Okay, great. So something like seeking funding. Anything else?
Literature review is usually the very first thing we familiarize themselves with, especially in a publishable manner.
Yeah.
But then for the simulators that we use it.
Great. So you can think about maybe some standards that you might want to set out for your students, kind of like, you know, we're hoping that by the end of this relationship that we have, that you'll have these skills and abilities. Anyone else? The thing I'm often asked, you know, that you need in letters of recommendation are about communication. So how well are students communicating with others about, you know, tasks that have been done in the lab? Did they get this done? What's a priority? If something didn't get finished that absolutely needs to be finished, was that communicated? And this can be done in a variety of ways. We have notes, we have a post-it board, we have email, you know, but, you know, it's everyone working together as a team and managing things with one another. You know, we have a certain amount of computers in our lab that can do certain things. If everyone's trying to code at the same time and only 2 people can, then coordinate with one another. Okay, I'll go do this for a while and then coding. And then I think this is critical to any area of science, is this attention to detail, that our students really being careful, following protocol to a T, following all the steps that are necessary. And if they're missing them, letting them know that it's a problem and how that can impact the research. And I think a lot of times framing like why those steps are important in terms of the research process is really helpful for them to understand why they have to do all these little details. And most of them figure it out when someone else messes up why it's a problem, because then they're cleaning up that mess. And then even things like time management, you know, does it take someone 15 minutes to just get settled and start working, or do they come in, see what the priority is and get right to work? They get it done efficiently and they move on to something else. And so so that's another thing that I think is important, is making efficient and effective use of their time in the lab, and that's something we comment on. So all these things we actually incorporate in their grade, but then I have other things on here. Well, autonomy is the last one. The notion is early on, you're going to be spending a lot of time with your mentee, right? You're going to be working closely with them, you and or graduate students. Well, you are graduate students, sorry. You're going to be working closely with them. But, you know, the idea is at some point, though, that they're going to need less and less supervision with certain tasks, right? But as new tasks come on, maybe you're at a point in the experiment where things are changing and it's going to require closer supervision again. But the idea is that with that early on supervision, that, you know, okay, within a few weeks, I'm anticipating you should be able to do this on your own. And are you showing that autonomy? Are you always coming to me with questions? And we have things in the lab like scripts and protocols that are available for students to refer to. We encourage them to take notes when they're training so that they can also be self-reliant for these sorts of things. And then these are other factors that will go into a letter of recommendation that we don't necessarily grade on, although you aren't going to say in my lab if you don't have a professional work ethic. But so pretty much things like solving interpersonal problems on their own, respecting the privacy issues regarding research, demonstrating integrity, all of that. And then another thing that I like to comment on, you know, if we've had a student that's just particularly strong, they're just acquiring skills, they're asking these questions, they're really showing this evidence of like higher level thinking. I want them to know that. I want them to know that we've noticed, and we really think that they're a great candidate for graduate school, for going on, and encourage like that inquisitiveness, that commentary to keep going. And so I always like to applaud them if we can in our evaluation that they are showing evidence of this, whether they're trying to solve problems on their own, or they're asking, you know, well, I understood this article, but I don't quite see how it relates to this, or I have a concern, you know, about the method they used, or they're coming up with a creative solution to something. So there can be a variety of ways they do this. And then the other thing is, as you brought up, the writing, right? That they had this paper, wrote sections, incorporated feedback. Were they able to really effectively convey this information? So that I could say in a letter, hey, they really show, you know, the potential for higher level writing, you know, more scholarly publications and all that, or do I think that they still need work? And at the very least, did they make that effort to incorporate the feedback? You know, because I think, frankly, being able to incorporate feedback is probably one of the strongest things you want a student to be able to do, even if they're not the perfect writer yet. If they can do that and improve, that's great. And then we usually ask for a 2-semester commitment with our students, but many stay on for longer, and at that point, they're pretty experienced. And then I like to give students an opportunity to be a head research assistant, which means taking on more responsibilities, like kind of more big picture view of the lab, which might mean training other students, kind of just managing things, that, you know, coordinating students and their efforts and all that, and giving them an opportunity to take more of a graduate student role if you see that promise in them. And a lot of students you'll know, you know, they're the students that they're just always there, they're dependable, they're reliable, they're so motivated. You're kind of like, please stay and do this. So giving those opportunities then to exemplify leadership, which is also something you want to write about in a letter recommendation. Questions or comments about that? Okay, so like I said, I put these out front, and then we get started on the mentoring, right? So let's talk about the different types of mentoring that there are. So the one that's probably been the most studied and the one you'll most think of is known as instrumental mentoring. And this is really where you're providing students with the support and skills so that they can enhance in their professional development. So they're going to learn the tasks necessary to conduct studies in your physics lab. They're going to learn the tasks necessary to be a successful engineer. They're going to learn what's necessary, you know, to write well in English, right? So what do they need? And there's various ways to do this, but a typical way is, first off, they're going to observe. So you might show them maybe good and poor examples of writing if you're worried about their writing. If they need to learn a procedure in the lab, then they're observing someone do that, and then you can see these students have trays in front of them so that they can try it on their own as well. So obviously the first thing is the observation, and so we'll usually have students observe a study a couple of times before they actually practice it. But we call it, though, as a dry run, so it's actually not a real study. We have another person in the lab pretend to be a participant for these human studies. And you might do something where you simulate something in your lab where you're not working with human participants, but sort of like, what are the steps you would need to do? Let's walk through the steps here. So you conduct this dry run. And then when they actually go to conduct the actual study, there's a supervisor there the first few times, so that if they do get nervous, which is natural, that there's someone there for support, to answer questions, to step in if needed, or to say, you're doing great, you know, and then move on to working independently. So instrumental mentoring can take many forms. So just simply training your student on lab protocol, for example. This is what we need to do when we set up for a study, when we clean up for a study, during the study, all the above. How do they deal with data? How do you compile data in your lab? How do you audit your data to make sure it's accurate and reliable? What are the steps needed for that? And then when it gets to analyses, what are the techniques you use? Providing opportunities for and feedback on their scientific writing, which we've already covered, but I think that that's really critical that students get those opportunities. Maybe guiding a student how to create and present a poster at a scientific conference. Thinking about how they should plan for and meet deadlines. There actually is a psychology article that just came out, and they say if you're planning for deadlines, don't say from this date and work forward. They say, what's the due date, and work backward actually. What do I need to have done to meet this deadline? So maybe you've just got your results and the poster presentation's in 2 weeks. Well, then we want maybe a final or close to final poster, 2 days before that, so you can actually practice it within its final form. So if you want that 2 days before that, then 3 days before that, you might want to have had maybe one where I gave you feedback on ready, and then the very initial one the week before, so kind of working backwards. So what do they need to do to meet that deadline? And this becomes more and more critical in your career, but I think that it's good to start thinking about these things early on. And ultimately, for a really strong student who has their own research questions, are you giving them the skills that they could go and independently investigate this research question? Do they know now what literature to go to, how to do a lit review, right? How to find the literature, how to integrate it, how to critique it. Do they know what methodology that they'll need to approach this with, and what concerns maybe there are with previous studies that use that methodology? Are they going to be able to analyze the data? Do they have the analytic techniques available to them? And can they thoughtfully discuss what those results mean? Have you given them the tools to do this? Because ultimately, right, if we're mentoring undergrads, we're hoping that they're going to go on to graduate school and become scientists, right? Hopefully. We certainly need more scientists in the US, but these are just examples of instrumental mentoring, but the idea is you're giving, instrumental mentoring is essentially providing them that skill set that's needed to be a successful scientist. But there's other types of mentoring. There's the socio-emotional mentoring, right? So this is understanding that you are working with a human being, right? And providing some social or emotional support. And this can be done in different ways. So maybe you've seen the student progressing in the lab and you convey that, I've got belief in your abilities, that you can carry this through, instilling some confidence in their capabilities. Establishing a relationship of trust. If you're working with someone on a study, you certainly want to be able to trust one another. And so be open and candid. And you can foster this camaraderie just by having shared experiences, and often just by working together in the lab. And when they do well, confirm your acceptance of that and your affirmation of their abilities and conveying that. And sometimes students are concerned. They might say, I've really got this and this down, but I'm having so much trouble with the analyses. And just listening to those concerns and say, okay, well, I agree that you're doing this really well. I think you do this a little better, and we'll definitely work more on the data analyses, And so it doesn't have to be all touchy-feely, right? But it is just listening, responding, and establishing, what hopefully will be a beneficial relationship for both of you. And maybe they are going to go do that poster presentation at the end of their time working with you, but they're really anxious about it, even though it looks great and they're comfortable. They're, I used to hate public speaking. Now you can't get me to shut up, but, so there's anxiety sometimes before presenting. And so, maybe you can talk to them like, oh, I used to be nervous too, or well, why don't we practice with the lab group? So at least you get that practice, like going through your poster and answering questions before you have to do that with a bunch of strangers. And so listening to their needs. Questions so far? Okay. So my colleague Rachel Robnett, it was really great timing. She gave this presentation last week talking about some other forms of mentoring she's just discovered through her interviews with mentors when they talked about what they instilled. How to instill confidence in their students. And one of the things she identified was known as transparent mentoring. And what this means is that there are challenges in the research process, right? We've been talking about conducting studies and all that, but let's face it, Sometimes we set up a study and it doesn't work. We have to go back to the drawing board and redo it and redo it, or finally it's like, okay, looks like it's working now, and you proceed, but then you get to the end, you're like, oh, these results weren't expected. Somebody broke the test tube. My husband's a chemist, so he deals with this in lab situation, so there are a variety of things that can happen, challenges and difficulties in the research process, right? And so we need to be honest with students about these, that it isn't always easy, and a lot of times you'll have more struggles than you will have successes, but the successes, I think, are what make science really exciting to be in. So convey this. It's difficult, but it's achievable. Be honest with them about these, and pretty much you have to work hard. You have to be really motivated and keep up with the literature, and that's really critical. And these are kind of all these nice kind of things, but this is also another component of being transparent, is you may have a student that is overly confident in their abilities, right? That they actually think that they're doing quite well, and they're not. But having that overconfidence can really impede their success. So you also kind of might need to be transparent that, look, I know that you're feeling good about this, but there's actually some concerns about your work, and there's that transparency. And that's not as easy to convey as this other stuff, but it's still critical. So they don't go away thinking that they have skills that they necessarily don't have. Questions about transparent mentoring? And then the other one is just sort of holistic mentoring. And this is, the fact of, yes, you are working as a research assistant in my lab, but I realize you have a life outside of academia. You do other things, and supporting those non-academic components. Now, I want to convey that these are things that came out of individuals' interviews in ways that they instill confidence. And instrumental mentoring is the top one, and socio-emotional. And these are small, lower percentages here in terms of the transparency and holistic. And you may or may not use all these components of mentoring, but I wanted you to be aware of them. So some examples here is just, what's going on with you outside of school. Some students are taking 4 classes, working a job, and working in 1 or more research labs, and they're very busy, and so they're juggling that. And so just acknowledging that, learning about that. And that students have strengths to overcome challenges, that strengths maybe you've seen in the lab that they can translate to their real world experiences if they're having challenges. And then the other is, many of you are probably going to be mentoring students that are from a different background as yourself, or a different gender yourself. They don't look like you. And that's okay. And it's good to acknowledge, though, that they have a different background and make some connection with that. Now, some people say, I'm not really comfortable bringing this up, but it's better to acknowledge that someone is from a different background, and you can talk about it, and you can see if they're comfortable with that or not. And students may bring it up on their own, and you may not feel comfortable bringing it up, but then respond to that. And I think it's important to recognize that we've all been raised different culturally, and we may or may not have similarities. Okay, so of all of these, what do you think is most important to attaining self-efficacy? So this is where a person believes they're capable of, becoming a scientist, that they have this confidence in their abilities. Yeah.
I think it's results, just seeing that you can do it. I mean, regardless of how much help you had, just say, like, this was my idea, and here it is.
Here it is. Yeah. And so what type of mentoring do you think would get them there? What do you think is the most important mentoring for predicting that then?
You gotta know how to do it before.
Exactly. Yeah. And so, I want to kind of leave you with that, you can pick and choose how you use socio-emotional, transparent, and or holistic mentoring depending upon your mentoring relationship, but the instrumental mentoring is critical. So this is a chart from Chemers et al. And so essentially the way to read this is, okay, so here we have a student who's had research experience that predicts their science self-efficacy, which predicts their commitment to science's career. It also predicts their ability to leadership and teamwork, right? important, and that makes sense if you're working within a research lab and all that, and having a chance maybe even to supervise others over time. But see, the instrumental mentoring here we can see is predictive of science self-efficacy, as well as the commitment to a science career. And it also predicts identity as a scientist, which predicts commitment to a science career. And so if you really are hoping to be most successful in getting the student to pursue a science career, you want to make sure that they've got that skill set. That's really the most critical component. And these other components of mentoring, as I just mentioned, the paper is under review about transparent and holistic. It was just discovered, so we don't even know their predictability right now. Socio-emotional mentoring has not been thought to, hasn't been found to predict this self-efficacy, but it might be important just for the relationship and comfort, right? So we don't know, the jury's kind of still out on that, but we definitely know instrumental mentoring is important. So at the very least, yeah, go ahead.
In regards to the socio-emotional mentoring, could that maybe be more helpful for specialization? Just have someone out there, sometimes especially at a conference, if you don't know anyone, it's kind of hard to meet people, especially if, you know, you think, well, they're doing all these great things, what I'm doing may not be as big of a deal or as, you know, paradigm changing.
Right, so maybe it's like taking the student, introducing them to someone who they're interested in meeting, and then starting the conversation so that they can then talk to them, because they may not, you're right, feel comfortable. I certainly was not comfortable going up and talking to people, even as a graduate student, but then my mentor would introduce me to, you know, the famous psychologists that I wanted to meet. And now I'm doing the same for my graduate students, that I start the conversation and I bring them in and then hopefully leave them talking with them. Okay, so I want to end on this very important commentary in terms of diversity. I don't know who the students are that you're mentoring, but I do want to note that women and minorities are underrepresented in science, and successfully mentoring these individuals is important. First off, the US has a shortage of qualified individuals in STEM, just in general, compared to other countries. So we're lagging in the STEM field already. And part of that is if women and minorities start off in a science field and get deterred for maybe possibly due to a poor mentoring relationship or for whatever reason they don't feel welcomed, we're losing some very potentially qualified people. So we want to keep these individuals in the pipeline. And we know that new discoveries are most likely to be made when diverse individuals work together. When you bring people in a room that have different backgrounds and perspectives, you can be so creative in that regard versus a bunch of people that have had the same experiences. And so to value this diversity. And so mentoring really provides this pathway to empower these individuals who are typically underrepresented in the field, and to do your best that you can to empower them. And one way is to discover similarities. It doesn't matter if we look alike or not. There's probably some life similarities, right? And you can always find a way to bond in that regard. And at the very least, you can bond on your similar research interests, right? But there's going to be differences, and respect those. You have a different cultural background than me, you think differently than me, but that doesn't mean we can't work on science together, right? And value the new approaches and input and perspectives to a problem, because it might get you to think of things in a very different way. So, and I will say though, there isn't really great research yet on how to foster mentoring diverse individuals, but I think being open to a dialogue is probably the most critical. Okay, so as I was writing this talk, I started thinking about all my mentors. So I just wanted to say that this was my mentor, Cindy Scheib from Ithaca College, from when I was an undergraduate. And so she's the first in line to bring me down, right? And so you can be the first person in line, you know. And then I took 5 years to find myself. And part of that time was in Seattle, and I found Dr. Angela Genorio at the University of Washington, who mentored in independent research with me, and also actually really helped me in applying to graduate school and how to approach that. And then probably the person who's had the most impact is my graduate mentor Dr. Judy Langlois from UT Austin, and we published a bunch together, and amazing lady. And then finally, I came here as an assistant professor, and you get a faculty mentor because you're going from a grad student to a professor. So anyway, I just want to acknowledge the mentors in my life and just to remind you that you are probably, hopefully, the start of a chain that can lead to bigger and better things. Questions?
Do you find that those 4 types of mentoring, they'll kind of conflict at some level? Like it seems like the holistic approach might conflict with the socio-emotional at times, depending on
Right.
If there are certain things outside of research that might have an adverse effect on research, but you don't necessarily want to bring that up as kind of oh, you're doing this wrong in your life or something like that.
Right. Well, and I think sometimes if someone's just having a hard time in their life, you know, like compassion, you know, and you may not be able to solve those problems, and you may realize, you know, I mean, if someone's had a death in the family, I'm always like, take some time off, you know, we don't need you in the lab, and people should have a chance to take time off and mourn a loved one, right? So I think that that's kind of sort of the holistic too, is understanding that someone might encounter challenges while you're mentoring them, and to say, okay, you know, take a few days off and we'll figure out how you're going to make up your time when you come back, you know, and I think just having that compassion and understanding is enough without having to be someone that can solve it, right? But kind of giving time sometimes, you know. Now obviously if it's a huge challenge and it's going to take an intense amount of time, you know, I've had students say, you know, I really need to drop out of the lab this semester, and but could I come back? And I say, of course you can, you know, like I hope things work out, and you know, so. But it's just reality, life happens. Yeah. Other questions? Yeah.
With mentoring, is it, because I'm seeing 2 different approaches. One is that, you know, the mentee kind of seeks out the mentor, kind of, you know, ask questions. I'm also a approach where, you know, the mentor looks out and sees, well, you know, I see a lot of potential in you. I think with the right help, you can be something. Is there one way or another, or does it just kind of happen organically?
I think both can be, you know, so say you're teaching a class and you've just got this student that talks, you know, I had a student who would come up and talk to me after class all the time, and I just said, you know, you really should get to a research lab. You just have this inquisitiveness that, you know, and so encouraging them to do that, you know, and noting students who might have that potential, right? And then there's other students who say, you know they want to do research and they seek us out, and then one of the things we do is like a pre-interview that they fill out online. And we look at their interview questions, and we interview them personally, and we decide who's a good fit in that regard. Because not everyone that wants to be in our lab is going to be a good fit, right? So, or has the qualifications. And it's generally pretty competitive. I don't know how it is across the university, but it's generally pretty competitive to get into the psychology labs. Other questions? Okay, thank you, everyone.